Hi everyone, welcome to Math Moment with Mr. Dustin. I'm Mr. Dustin. So today we'll be discussing solving linear systems. Now this is a concept generally introduced in Algebra 1, which could be 9th or 10th grade depending on the curriculum of your high school. And so there's a formative assessment you can take. The link is in the description below. And at the end of the formative assessment, there is a code you can enter for a virtual visitor badge. So I encourage you to take the quiz and earn that badge. And so yeah, enjoy the video. All right, so today we'll be discussing solving linear systems. Now what this means is we're going to take two or more linear equations and we're going to find out where they intersect. In other words, when can the x and y values apply to both of the equations? And so what I'm going to do is I'm going to demonstrate this visually, all the scenarios that you can have when trying to solve linear equations, and then we're going to go into some examples of how this actually works and how to actually solve them. So what I have here is a graph of these two lines, and where they intersect is at -1, 3. In other words, when x equals -1 and y equals 3, these two equations are equal. This right here is known as the solution. In this scenario where they intersect, there's only one solution. And so you can see that they go on forever and ever in their opposite directions, but they only intersect once in this middle point here. So that is why there is only one solution. Now, here's another example of it having only one solution. This time it's at 3, 1. So when x equals 3 and y equals 1, that's where the solution is. And then the same can be applied here when x equals -1 and y equals 8. That's where the solution is. It's the intersection point of the two lines. And so that's generally what you're going to try to find when solving the linear equations. And we'll get into the how of that in the second part of the video. And you'll notice that the equations aren't in your typical y equals mx plus b format. And that's okay. We can work with them like this. We can manipulate it to become y equals mx plus b. For example, you know that you can add and subtract things from both sides of the equation and it'll still be okay, right? That's what we know from being able to solve for x when we're given everything else. The same applies here. If I were to take this top equation and add 3 to both sides, now watch the red line, okay? I'm going to take away 3, or the -3, because when you do -3 plus 3, that gets you 0. And then we're going to add 3 to the side, and look at that, the solution is still -1, 8, and it's y equals mx plus b format. So that's essentially what we're going to be working with in the second half of the video. We'll be working on converting it like that and then solving for the rest of the missing pieces. Now here's another scenario of solving for linear, or solving linear systems where you don't have any solutions. Now, we've seen where you can have one, but this is where you have none. And you can only have no solutions when the two lines are parallel. In other words, the slope is the same. Now, the slope in this case is 4. And so the two lines have the same slope. However, what makes them different is the y-intercept. In this case, if I were to convert this -5 back over here, we're going to just take care of that. We have a y-intercept of 5 in the second equation, but a y-intercept of 0 in the first equation. And that's what makes these different. And that is why there's no solution. It's because the lines are parallel and they will never touch, even though it looks like it visually here because they're so close together. They never touch, and that's why there's no solution. Now here, we have something that has infinitely many solutions. In other words, you can't count how many solutions there are because they're the same line. You've basically taken one equation and then copied it over to the next thing. All I've done to get from the first equation to the second one is I multiplied both sides by 2. So you have 2y equals 4x plus 4. That produces the same equation as the first one. If I make the blue one disappear, you have the red one. Just like that. So that is why there are infinitely many solutions. The y-intercept and the slope are the same in this case. And so that's what sets it apart from the scenario where you have 0 solutions, and that's what sets it apart from our other ones where you only have one solution. So after the break, we will observe all of these scenarios algebraically. So we'll be solving them for x and y to find either the one solution or discover that there are no solutions or infinitely many solutions. So stay tuned for that. So Jen, I'm pretty psyched about making some puns today.
Well, that's great, Dustin.
I guess you could say I am the king of pun making. I guess you could say I'm so good.
At sewing?
No, at puns. So Jessica, I'm gonna volley some puns off of you. Is that all right?
Grown, yes.
So have you seen my water bottle?
I haven't.
I'm not sure where it is. I guess it's a mystery. Hi everyone, welcome back. I hope you enjoyed the break. So now I'm going to introduce you to 3 different methods to solving the systems of linear equations. So the first one that we're going to go over is just by setting them equal to each other. So I'm going to give you 2 equations on the whiteboard here. Y equals negative 5x plus 3 and y equals x plus 9. So here are our 2 equations. And what we're going to do is we're just going to set them equal to each other. And we can only do this right now because both of them are y equals something. If they were in another format, we would have to change it to be y equals mx plus b. That's the easiest way to do it. So now I can say negative 5x plus 3 equals x plus 9. So this is our next step here. And from here, we know how to do this. We can just get all the x's on one side and all the non-x's on the other side of the equation, and then solve for x. So let's do that. I'm going to add x, or 5x, to each side. So that gets me 3 equals 6x plus 9. So far, so good. Now we'll subtract 9 from each side. So now I have negative 6 equals 6x. So this is where we're at now. Now I need to get x by itself. We divide by 6 on both sides. And that gets us negative 1 equals x. That's only half of our solution though. So I'm gonna, let's see. We're gonna put x in for x in one of these initial equations. That's how we're gonna get y. So I'm gonna use the second one here. So I'm gonna say y equals negative 1 plus 9. And then just solve for y. So negative 1 plus 9 is 8. So y equals 8. So now I know my solution is going to be negative 1, 8. And if you remember back from the first section of the video, that was the solution to one of them in the graph. You know. So now this is a way to check it. If we want to check the answer, we put this back in both of the original equations. All right. So I'm going to say 8 equals negative 5 times negative 1 plus 3. Well, I know that negative 5 times negative 1 is 5, and 5 plus 3 is 8. 8 equals 8, so this one works for the first one. Now the second one, I'm going to say 8 equals negative 1 plus 9. Well, we already did that down here, so we know that this one works. And now that we've checked it against both of the equations, we know that this is the accurate solution. So that is how to use the setting them equal to each other form or like method. Now I'm going to erase this and then show you the second method. Now the second method is called the substitution method. And it's basically going to involve taking part of one equation and substituting it into the other. So I'm going to use y equals, say y minus 2x equals 5. and y equals negative 3x. So now that I have my two equations here, all that the substitution involves is saying, hey, y equals something, or you could say x equals something. It can go both ways like that. But hey, y equals this. Well, why not just put it in here for the y? So that's what we're going to do. We're going to take this portion, the negative 3x, and put it right in there. So now we have negative 3x minus 2x equals 5. Now we can solve for x in this, in this equation. So I'm going to combine the negative 3x and the negative 2x. So that's going to be negative 5x equals 5. And then we get x by itself. So we'll do that. Divide by negative 5. And then x equals negative 1. So that's x. Now for y, we do the same thing as before. We put x in for one of these original equations and then solve it for y. So I'm going to use the second one again. Y equals negative 3 times negative 1. And that will make y equal 2, 3. Because negative 3 times negative 1 is positive 3. So these are our two values. So now I have negative 1, 3 as my solution. Well, let's check it. We already checked against the second one, and that's how we got this answer. So we know it works for the second one. How about the first one? Well, 3 minus 2 times negative 1 equals 5. Well, 2 times negative 1 is negative 2. When you subtract a negative like this, that makes a positive. So it'll end up being 3 plus 2 equals 5. And that is an accurate statement. So we know that it works for both of them. And so this is our correct answer. And you'll remember it could be one of the other graphs that we saw. So now I'm going to teach you the third method, which is called elimination. Elimination is designed to get rid of one of your variables, either x or y. You're basically targeting it and saying, no, you are not going to exist anymore. So basically, I'll put the equations up. Just like so. Now, before we do anything, I want all of my x's and y's to be on the same side of the equation. So I'm going to adjust this one. This is the second equation right here. So I'm just going to make an arrow. So these are the ones we're working with now. All I did was I subtracted 2x from each side of the equation. That's all I did to make it this way. So now I'm going to be thinking, well, how do I get rid of one of these variables? Here's the trick to elimination. You can multiply an entire equation by something and then add the two equations together to eliminate one variable. So allow me to demonstrate. I'm going to multiply this whole bottom equation by negative 1. So that's going to give me two equations again. Y plus 3x equals 10, just like before. And then negative y plus 2x equals 5. And that's after multiplying this second one by negative 1. Now, when you multiply an equation by negative 1, or anything, you have to multiply both sides. So that's what I did there. Now, we add them together. So y plus negative y gets me 0. It's like saying I've targeted this y and it is gone. There's no more y. And then 3x plus 2x equals 5x. And then 10 plus 5 is 15. So as you can see, I just added these together and they made this new equation. Now, it's like we've seen before. We can just solve for x. So divide by 5, x equals 3. And then just like before, you can plug x back in one of these equations and you'll get y. So I'll use the second one. Y equals 2 times 3 minus 5. And so 2 times 3 is 6, minus 5 is 1. So y equals 1 and x equals 3. And so I'll do this, 3. Now, again, we can check it, but I trust by this point you know that we can check it and it'll work out to be all right. Now, there are 2 more things I want to do, and it's going to be to show you when there are no solutions and when there are infinitely many solutions. Up until this point, we've only done stuff that comes out as one solution, which is good. That's what you'll see most of the time. But there are going to be instances where you'll see it as 0 solutions or infinitely many solutions, and I want to introduce you to how it's going to look. So this is going to be our infinitely many solutions system here. Now, I want to use the method where we set them equal to each other. So I want just one y. And so what I'm going to do is I'm going to divide the second one by 2. That gives me y equals 4x, or not 4x, sorry, 2x plus 2. And so now I can set these 2 equations equal to each other. 2x plus 2 equals 2x plus 2. Already, you may be thinking, well, of course, these are equal. They're exactly the same, and that's kind of the point. That's what you want to recognize. But if we go through it, now I can say 2x equals 2x. Uh-oh, well, now I want to get my 2 x's on the same side, so I'm going to subtract my 2 x's. And, oh, wait, 2x minus 2x is 0? It also equals 0. So, yeah, when you get to this point, you know for sure this is infinitely many solutions. 0 equals 0, like there's nothing left. You can't do anything else. So you can conclude, oh, these are the same equation. So that's what infinitely many solutions looks like algebraically. Now, finally, 0 solutions. This one is a little more interesting, I think. Y equals 4x, and then y equals 4x plus 5. It's already in the format we like, so I can just set them equal to each other like we've been doing. So 4x equals 4x plus 5. Now, I want to get all my x's on one side, right? Just like we've been doing. So I'm going to subtract 4x. Well, 4x minus 4x is 0. 0 equals 5. Now, is that an accurate statement? Does 0 equal 5? No, it does not. So because this is an inaccurate statement, you know that there is a red flag. And then you can conclude that there are no solutions to this because 0 cannot equal 5. 0 will never equal 5, just like 4x will never equal 4x plus 5. And when there's a solution, they're equal to each other. And if they're never equal to each other, there's no solution. So that's kind of the idea behind solving linear systems. And those are the 3 methods along with how you'll see, no solutions and infinitely many solutions. So there is a formative assessment you can take. The link is in the description. And there's also a code at the end of it you can enter for a virtual visitor badge. So I encourage you to take the quiz. I hope you enjoyed this video. Thank you so much for watching and enjoy the rest of your day.